you're on. I'll just do this as well. Yeah. Okay. Good to go?
Yep.
Okay. Hi everybody. My name's Richard Reed, for those of you who don't know me. I've been at Arup for about 13 years now. Spent a lot of my time in consulting, working mainly with the Building Performance and Systems team, but also in advanced technology and research. My background is as a HVAC controls engineer, looking at designing and performance of buildings, and also how we integrate systems in buildings and bring them together. Since February last year, I've been in Building Engineering London, leading the Smart Buildings team there. And over the last year, a lot of my work has been around how we deliver smart buildings, mainly focusing on enablement of smart buildings. And our biggest client has been British Land, where they're a smart building consultant across their portfolio of buildings. Also, I'm a product owner for the Property Insight project, which is a globally funded project that's very similar to Movement Insight, that's been worked on over the last few years, and is essentially funded from Volker Busch's data-driven business. So, what I want to talk to you about today is our work with British Land on smart buildings. And so, as a bit of background before we get into that, I want to talk about, what is an intelligent, integrated smart building? What are the different architectures that have appeared over the years, and why and how smart buildings now is different to what has historically and traditionally been delivered, and the kind of pitfalls and benefits and pros and cons of each of those approaches. Then I'll talk about the work that we're actually doing with British Land, what their angle is on it, why they're bringing that to the market, and how they're rolling that out. One of the most kind of key and underpinning parts of this whole thing to make smart buildings work is about a naming strategy and an asset information register, and how this allows us to understand the data that's coming out of buildings so we can do things like analytics and machine learning on it. The design guidelines that we've created for them, some early market feedback that we've had from a manufacturer who's actually implementing our approach on one of British Land's projects. And then we have, we're just kicking off a software proof of concept that's kind of co-funded with British Land and the Property Insight program that I've mentioned just a minute ago. And so I'd hope to get some nice pictures, but I ran out of time. But just to give you some context of who we're working with and who's working on this work with British Land. So in the top group is mainly people in building engineering in my team that have been working specifically on helping British Land implement the strategy. Then the second part is the networks, and that networks team, and that's absolutely key in terms of how we can exchange data between different systems. And so the networks team in the SII team in ADE are delivering that work and delivering a set of design guidelines for British Land around networks as well. And then finally, the group of people at the bottom there are working on our software proof of concept, and that is the team, the data team, the team of data scientists, cloud architects, data engineering, that are helping us to complement our domain expertise so we can start getting data out of buildings. So just to kind of recap on where we are, what's happened in intelligent buildings over the years. So I've got a set of diagrams now that I hope we can run through and you will understand what happens in buildings. So this first diagram is a very traditional approach that is commonly what you'll see in most existing buildings today, which is that every single subsystem has its own network. So it will have its own physical network for all the devices. It will have storage for that subsystem, and then it will have visualization. And those subsystems don't communicate to each other and exchange and share data. Then separately, we'll have a common network for the corporate organisation, and that's where you might see room booking systems, how audio-visual systems, security devices connect into the building. And what we've tried to do there is enable you to see that on a new project, who the roles, who the organisations might be that are delivering each thing in that project. If we move forward a little bit better, is that we get a common physical IT network. So these individual subsystems are still in vertical silos with their own devices, their own storage, their own visualization, but they're sharing the same IT infrastructure. Now, this is really useful for two reasons. One, it means that the people operating the building, from an IT perspective, know all the devices that are on the network. And it also means that it's controlled. So these individual subsystems aren't getting rogue connections to the internet that people don't know about and then starting to create a possible security issue. So that's a step forward, but we still can't exchange data between different systems. So now, when the next step, and this is the traditional approach to integrated building systems. So when we hear about integrated buildings, historically, you still have these vertical silos of systems. They're sharing a common network infrastructure, the physical backbone, the IT backbone. But now there is a middleware platform that translates all the information, the language, from English to French or whatever the common language that we need to use, so that we can start doing something with it. Now, this approach you would typically see delivered by someone called a master systems integrator, and that would be one organisation. Commonly, it's also one of the big manufacturers, so someone like Honeywell or Schneider. And so their approach is that they're really trying to create a lock-in. So they want to take all of the data from all the subsystems. They'll create their own proprietary bespoke middleware solution, and then it will be their application that sits over the top. And therefore, you don't get the flexibility of picking and choosing applications that you might want to use as an organisation. And also, you're tied into a long maintenance contract thereafter. And so the other point here is the green boxes there. There are gateways. These are the translations. So if my BMS system talks BACnet, then I might need to translate it to another language to put it in the middleware platform. If my lighting control system talks KNX, I might need to translate it. Metering, Modbus, translate it. So everything understands and communicates in the same way. So the next step is this kind of hybrid approach. And this is where we still have gateways, but we're using, and this is part of the way where we're at now, which is we're trying to create this small, thin data validation layer, whereby implementing a common naming convention, and saying what protocols those systems must talk, we can ensure the data that comes out, we understand it. Then that data can get passed into cloud platforms like Amazon or Google or Azure, whatever it might be, and converted into internet protocols that software developers would understand, and they don't need to be domain specific, so they can start analysing that data and creating really nice applications. And then the final step So the difference here is, I'm going to get up now, so I don't know if you want to. So here, we still have these gateway devices. And that's because these traditional devices are very archaic and they don't have internet security standards, they don't speak internet protocols. So we still need to do the translations to get out to the internet. Where the industry is moving towards is that we just have intelligent devices. We don't have a BMS system, we don't have a lighting control system, we have intelligent devices, they're secure, they talk the right language. We still need this data validation role to make sure everything's named correctly, but that can probably be automated and should be automated to speed that process up. And then we can get stuff out into the internet and we can choose applications from anybody, or we could develop our own applications to get kind of best in class. Okay, so that's kind of background of where kind of intelligent buildings, integrated buildings, and the direction of travel. Is there any kind of questions on what I've gone through at this point?
The smart devices where you say it's moving towards. So how many buildings, like what proportion of buildings now, will have those old school legacy devices? And how long will it take them to get all smart devices so that those foundation layers valid itself?
So I'd probably say like 98–99% of buildings still have those devices that aren't intelligent, and actually it's a real, the domain specific, your lighting, HVAC, metering, lifts, don't have intelligent devices really.
So this new thing here is targeting just sort of new developments, really?
New and existing, because what we're saying is, sorry?
That 2% that have them already.
No. My point, you asked which percentage of buildings have intelligent devices.
Yeah.
98% don't have intelligent devices.
So 2%, sorry, yeah, the 2% that do, and new ones.
This approach targets everything. So the idea is you might still have all of these vertical systems, but we'll put a gateway in, and we'll apply our naming standard using the right protocols. We'll validate it, and then you can transfer that data to cloud, and then we can start doing something with it. But that's the piece I'm going to come on and talk about. There's a big enabling process before we can actually start getting that data. So on new buildings, it will be much easier because we can get the naming standard correct in design. On existing buildings, we have to find a way where we suck up the data and either manually label it or write script to automate the mapping between the existing names and the naming convention that we actually want.
And is the naming standard, is that an open naming standard?
Another good question. So, so the naming the naming standard that we've been developing. Sorry, 2 seconds. Okay, so the naming standard we've been developing is based on industry best practice. Okay, so there are a number of initiatives happening. One's called Brick Schema, which is based on linked data. Another one's called Project Haystack, which is based on semantic tagging. And then there's another one called Building Ontology Topology, which is developed by the W3C Internet Standards Organization. We're trying to look across all of those and develop something that whichever direction the industry takes, whatever we develop will be reusable on whichever direction the industry takes. ASHRAE, so the US equivalent of SIBSI here, have a working group with BACnet, Brick and Project Haystack to define a naming convention, and it's hoped that that will become an ISO standard, for instance, in the future. The other thing we're considering is all the naming convention work we're doing, should we open source that, put it into the marketplace for everyone to use, and our advantage is all the extra bits that we build around that naming convention, like the ability to go into existing buildings, automate the process for mapping or whatever extras we might build around that. So, okay. Okay, so British Land, what are we doing with British Land? Okay, so our role with British Land over the last 12 months has been to create design guidelines for enabling all of their new buildings and all of their new developments, and also creating this naming convention and applying it to their projects. Simultaneously, we've been appointed to, and really importantly, because it needs to be hand in hand, we've been appointed to write their network design guidelines. And then thirdly, that first bit on building enabling, smart building enabling, is for their base build shell and core projects. And the third part is to write a set of fit out design guidelines that talk about all the possible use cases that British Land might offer to their tenants. So that could be around space utilisation, wayfinding, it could be predictive facilities management, all the environmental sensing, things like the IOT desk. And so their proposition is, if we offer those services, can we offer X pounds extra per square foot on our rental? Or can we offer as a service approach where the tenant pays on a per user or a monthly fee? So they're trying to differentiate themselves in the market versus their competition that develops and operates buildings. So this is a very simplified diagram of the one I showed a little while ago, which is basically saying we have all of those subsystems at the bottom. At the moment, we need gateways to translate the data from those subsystems into a common language. And then that common language is a protocol called MQTT, which is an internet protocol that gets sent up to the cloud. And then there is a database, a broker, that takes all of that data from all sorts of different databases, not just building systems, and puts it into a place where it can be understood because the naming is common and clear for all of the information there. Then you can pick and choose either best-in-class applications in the industry, you can build your own, however you want to do it. And what's good about this approach is then it really nicely scales. So you do that software, sorry, I should have said below the line is within the building, within the construction project. Above the line is outside of the construction project, where we're not constrained by practical completion and liabilities and time pressures. We do all the software development outside of the construction project. So the below the line is all about enablement within the construction project to make everything smart ready. Then outside of the construction project, we go to the best software design house, or it could be Arap's data team, who can then build the software platform and then connect the various apps. This gets built once, which means it then can be reused on each building or each project. The traditional approach that I told you earlier from the big players like Honeywell or Schneider goes vertically top to bottom. So you pay a huge amount of money because each building is completely unique. Whereas what we're doing here is standardization and making sure we can reuse all the software components. Okay, and so this is the approach that we have for British Land at the moment. Similar to what I've shown you earlier, we have each vertical subsystem. What's really important here is that because of that construction project pressures, we still ask the individual subcontractors to deliver the devices, the storage and the visualization. That means that they can deliver the HVAC controls or the lighting control system, get to practical completion, walk away, deliver the project on time, on budget. The additional piece that we're asking for is this gateway, the bit in orange, and this is where we do that kind of data validation piece. So what we're asking for is, please make sure that gateway exists, please make sure all the data is named and labelled in the right way that I wanted it. Then the data can be sucked up into cloud, and then we can implement the smart use cases when the fit-outs happened in the cloud. The applications, as I said, are in yellow because they can be from any application developer. The cloud platform developer is all in purple. It could be our app, could be a third party, could be off a shelf. All of that's up for grabs, basically. And just to point out, in time, those gateways will not need to exist. And something that I'll go on to explain where that's happened with lighting control system already on one of the British Land's projects. Okay, so that's given you the context of what we're doing for British Land. Now the kind of underpinning piece, the naming strategy, the asset information register, it's the dry bit, but it's the really important bit. So, as an example, you have in every building and every HVAC control system commonly or hopefully would talk BACnet. BACnet is an open protocol, or perceived as an open protocol. It's not truly open because every single manufacturer has their own engineering tool. So even though I'm talking a common language, I'm still locked into that manufacturer because I need to know how to use their engineering tool. I have to pay for it. When a temperature sensor is defined in BACnet, it gets a description, and the name could be anything you want it to be. So in this case, it's outside air temperature. When I go into buildings and I suck up all the data from the buildings, whether that's temperature sensors or valves, some of them are called temperature sensor, some of them are called temp sense, some are called TS, some are called TWX. How do I know I've got all of the temperature sensors that are in the building and all the information that I need? So this is where we need a consistent naming. So our strategy, or our asset strategy first, and then I'll come on to the point strategy for British Land, is that every device must have a unique identifier, and that's a machine-readable label. So an individual would not understand what that machine-readable label means. Then we have a device type name, an instance name, parameter data, and physical label. So I'll talk through each one of these steps now. Okay, so a device instance unique identifier. As I said, this is a code that that a human wouldn't understand what it was, but it is globally unique. So it's infinitely, it's basically impossible to regenerate this code again. I think that it's like, if someone generated one every second for the next year, and you developed like 5 billion of these things, there's like 0.5% chance of being able to regenerate it, something ridiculous. So trust me, this is completely unique. Okay, next step. So this is where we start going into something that building services people will be more au fait with. So a device type name. So this would be, the first part, the type enumeration would be something like AHU, Air Handling Unit, or FCU, Fan Call Unit. And the second part of it is free text. So you have the choice on your projects or as part of the FM team to call it whatever you want. So on an MEP project, you might say I've got type A, type B, type C air handling units. Then I get through to construction. My type A units are built by Flat Woods. My type B units are built by New Air, and so on and so forth. Then we have the device instance name. So that is saying we have air handling units. They start at 1 and they run to 12. We have 12 air handling units in the building. Each one is unique. So that's just adding the kind of the asset information. Then I've already mentioned brick schema, project haystack. This is when we can start adding really useful additional information to that name. So if I can associate with that temperature sensor that its location, the meeting room it's in, what it measures in degrees centigrade, the plant it's associated with, all of a sudden I have a much richer data set about that temperature sensor. On the left is what's called a graph, and this is how you link information together. So that temperature sensor is associated with the VAV in the room. That VAV is associated with the air handling unit, and it's associated with the power meter. That temperature sensor is also part of room 101. And if I had a PIR on the lighting system in room 101, then I could be starting to switch on the air handling unit and the terminal units based on my association with the PIR on the lighting system. So this is how we link data together to get interoperability between systems without having to physically connect them with wires, and why we can stick with those vertical silos that I talked about earlier. So the final part of the asset labelling is the physical label. So our approach for British Land is to use a QR code. So every asset will get a QR code. That will have the human readable label that is typically and recognisable to the operational FM as a minimum, and then we could also add the unique identifier. And also on the bottom one there, we add the typical information that, say, an electrical engineer would be used to, the flexibility to add that. So that is distribution board 1, it's on level 4, core 3, and it's small power. So your operational FM engineer will understand, just as they always have, what the information means, but critically that QR code relates to all the asset information and the CAFM system that allows us to maintain the building properly and understand about that asset. Now the key point here about the unique identifier at the bottom, the machine readable code, that never ever changes. So if that light fitting or that distribution board is broken and gets thrown away, that code, that machine code, gets thrown away with that light fitting or that distribution board. The new one gets put in place and it's still called DB001, but it has a new unique number. That means through my audit trail I can see, right, light fitting 001 keeps breaking because I've repeatedly changed the unique identifier. Okay, so that's what we've talked about there is physical assets. Now we get into the element of control system points. So these are digital points, software points that give us information on the system. So it could be the supply air temperature, it could be the space temperature, CO2 levels in a meeting room, it could be the position of a valve. And each one of these also needs a machine-generated unique identifier and a name. Unique identifier is the same as before. And then we generate what's called a point instance name. So typically, again, this is something you'll understand. So it's a fan core unit, FCU. It gets counted up 001, so these are already defined. And then we have a small piece of text that says HTG, heating, VLV, valve, CMD command. So straight away I know that's a heating valve command on the fan core unit number 1, and that is the same, the same letters for the point type enumeration every single time. This code then gets physically put in the control software. So when the commissioning or the software engineer comes along to engineer the BMS or the lighting control system, right back here, when I talked about this BACnet object description, this is where I would put that identifier in the software. Okay. Okay, so that's the naming convention. So one, the critical part for getting data out. The design guidelines that we've created that will be given to every design team that is delivering a project for British Land has additional information about the type of protocols that each device must communicate in, i.e. the language they're communicating in, and also all the industry standards that they must comply with, whether that's to do with Ethernet or internet protocols. And this is really important because this then allows us to deal with things like encryption, authentication, and how we do updates to devices to ensure that they continually stay secure. And that's so important. If they're connected to the internet, then this provides a kind of security possible for a security breach. This is the area that the domain of buildings and systems in buildings is typically really far behind. So if you went and bought an Internet of Things device that had nothing to do with buildings, then it will probably comply with most of these standards because it's developed probably by IT and software people, whereas the buildings domain is just way, way behind. 80s, 90s, come from a building services background, not an IT background. The second point that's really critical is that not only how we can say this building is smart enabled is by saying not only have we got the name and the abbreviation that's always the same, is that actually when you design and implement the building, these are all the points that we actually need to be made available. These are the ones that they only need to be read-only, or this is the point that we need to be able to write back, i.e. I want to change the temperature in this meeting room. I want to turn the air conditioning on and off in this meeting room. I want to turn the lights on and off. So by defining that in our design guidelines, we're ensuring that when it gets specified and then implemented, the information will be available for any of the possible use cases that British Land are looking to implement. Okay. So market feedback. So any questions at that point?
Yeah, so I sort of been in meetings where getting this sort of stand on the device name is a relatively easy sell, but getting the point instance, getting the point names and the GUIDs on the points is much harder sell to the MSI. I was wondering what the use case is for sort of this level of detail on the point.
Okay, so if it's done at the right time, there should be no resistance from the MSI, because every contractor, when they do their design and implementation, has to name something. So they will decide, I'm going to call that CVM 001, or I'm going to call it TWX 001. All we're asking and saying is, please call it what we want you to call it. Therefore, if you do it early enough and define it early enough, there should be no resistance. The use case is that if it's all called the same thing and it's all normalized, well, we can suddenly start doing analytics, we can do machine learning, we can actually start writing back to things that are in buildings.
None of the use cases work without that second stick.
Yeah.
Just having the fan unit named means isn't that useful.
Yeah, so I'm just thinking if you had a fan core unit with a unique identifier, so the device has got a unique identifier.
Yeah.
And then it has supplier temperature for the point name. You've got obviously the device name, which is the fan core unit, which has a unique identifier, and unless it has like 2 supply air temperature sensors, then it's just a. Do you understand? It's just a nested. It's just a point within a device.
But the point is that you could have, if they're fan core units, you could have 600 units that have supply air temperature. And how do you know?
But the fan core unit's has got a unique identifier.
Yeah,
Device
but
is a unique identifier.
but there's no guarantee. There's
Yeah.
no guarantee that that fan call unit name will follow through with that sensor value. So when you use that backnet object doesn't associate the fan call unit name with it. So when you suck that up into a database in Azure or AWS, you just have supply air temperature. Also, if you've got an 11th floor building, frequently you'd start fan call unit 1 on every floor. So then how do you differentiate between the 11 supply air sensors on the different floors?
They'll be on a different device.
Yeah, but what Richard explained, that you don't have necessarily, you can't rely on having the device name in your backnet.
It won't be there. It will just be,
So in BACnet rather than MQTT.
yeah,
Yeah.
Which is where the, so, but you're hitting on, this is the crux of it. How well our industry responds is the crux of the question, and we're kind of learning. Which has got a positive example coming
yeah.
up, and there's also negative examples, and we are going to have to adapt our approach to what we find from these suppliers, and maybe we have to introduce a translation step. But the bottom line is they have to be consistent in that subsystem. Otherwise, you can't understand what's coming out. If they're putting spaces in, or using capital letters and lowercase indiscriminately, it becomes much harder. Yeah, you can eventually correct for it, but it's much more brittle.
But yeah. So are we clear that it's on BACnet that it causes the issue, that is needed, and on MQTT it's less?
So MQTT doesn't have any association. MQTT is the transport protocol. The JSON payload has the associated information.
But basically, I'm wondering whether it's the things I'm stretching the limit. So whether if it comes into a cloud database,
Yeah.
you're going to have the brokers. You're going to be connected to. You're bound to have the device name, the unique device name that comes in with all the points data, right? So I'm going to be when you look through on the database, all the points will be associated with a device, which will be unique. Yeah?
Not necessarily. Yeah, because
well, if they're following your standard, if they're following the standard that you have, then
the standard you get even better.
yeah. But what I'm saying, if you take away the points bit is quite onerous. So if you take away the points bit, and you're getting it in the database in the cloud, if you've got the unique device, and that device ID is associated with, let's say, supplier temperature sensor, then you can in the cloud you can make that analysis. But I'm wondering whether in the BACnet world, which will probably not be connected to the cloud, whether it's there that there's the use case for having the unique points, because I'm less aware of that, but it may be harder to do it. It may be harder to do a search.
To get what you're thinking of, the JSON with the device name and some random points within it.
Yeah.
You've still got to get it from the BACnet or from the Modbus or whatever it is into that form, and so you need
To
a
map it.
machine to map. And
Okay.
if that mapping is manual, like a manual kind of list, it's
So it's
very
mainly
vulnerable
it's
to
the
change.
BACnet world.
no, it's all control systems.
All control systems are different, and so the internet and the buildings are disconnected entirely.
Yeah,
from
so
that.
if you-
this is a mechanism to
so
connect
if you
Can-
diverse buildings.
Can I suggest, like,
Yeah.
this will go on, right?
Yeah.
We should take this out of
Okay.
right now.
Yeah.
Let me finish my presentation, and then very happy to debate it on Yammer or continue to work out so we can kind of explain the rationale. And even I think when you think you've cracked it, there's all sorts of permutations that come up. So for a long time we debated whether we actually needed a machine readable identifier for the control point, and just couldn't see. But the conclusion was it was really important. So there's been a lot of thought, and we're happy to continue to adopt and revise. But yeah, I think this will go backwards and forwards for quite a while, and I think we should.
Can I ask a question about units and points? So one unit has many points, and a point can be like a switch or a sensor or a...
Okay, and this will this next bit will answer that question, I think. Okay, so 1 Finsbury Avenue is our first kind of project with British Land that's being commissioned at the moment, which is adopting the naming convention. All the subcontractors are adhering to it and adopting it. Simtronic, which is the lighting control system in that building. We also have Simtronic in this building. I think they take about 60% of the London market for lighting controls, something like that. They have been very, very positive about implementing our naming convention. They have also, in conjunction with Francesco over the last couple of years, first of all, developed a BACnet server so that they could, because they are a proprietary system, so that we could get data from their system and in a common language. Next step, Francesco's convinced them to develop an MQTT server. So now we no longer need the gateway, because they're exposing MQTT right down at the subsystem level. They have adhered to our naming convention and applied it to 1FA. And what's so interesting about this as an example is they've said, right, it will cost £18,000 to deliver this. So in terms of that and that building has 6,000 luminaires. So a luminaire would be a hardwired point, okay? So not necessarily a lighting controller, it would be one physical light, luminaire, yeah? Associated with that luminaire could be 10 software points, right? So I switch it on and off, I can change the light level, I might monitor it for its status, whether it's in fault, okay? Okay.
So building services are primitive, but they've got quite a lot of information out there.
So from this alone, we'd have 60,000 software points. That's right, yeah, 60,000 software points. Typically, the industry says to deliver you a software point will cost somewhere in the region of £50 to £200 to engineer it, to deliver it, put it on a visualization. So Simtronic are delivering it for 30p per software point. And so it's a really good example of a company coming along and buying into the approach because they see a market for them and their system moving forward in this kind of world.
That price you're talking about is the price for the subsystem. If you buy middleware on top, there's more to pay for the middleware.
And also what it means is that when something gets changed, you know, with a middleware approach, when something gets changed down here, it also means that I've got to re-engineer it in the middleware, and I've got to re-engineer it.
Shows of the Simtronic software, and it's if you just tried to link one of the PIR from the electrical sensors to the software, and it was not trivial at all. Yeah.
Okay, so that's really good market feedback. Whereas other contractors and suppliers are saying, right, this is £100 grand to implement this. So, you know, there's a big disparity, which with time will kind of work its way through and will be in a much better place.
So is this a one-off cost for this particular job?
Yeah, and this is a one-off cost because it was the smart enablement came midway through the construction. So had we got this all in at the design stage, you wouldn't see this cost because it would be adopted into the lump sum cost to deliver the lighting control system.
Simtronic have taken a long view. They haven't charged their entire development time in that project cost, but they can now roll out their new server technology to all projects and actually retrofit it to buildings like this.
Yeah.
50% of London real estate.
Okay, so the final piece that I wanted to talk about was our software development now with British Land. So our work so far has all been about enabling their buildings, making them ready, getting the data out, but then simultaneously they're also building or have the desire to build a software platform which will allow them to get the data, to interact with the data, to link with tenant systems and provide the use cases. For instance, if I'm a user of a building and I arrive, before I arrive, I want to pre-book a bike space. I want to know that I'm going to get a bike space today because it's just like so super busy for bike spaces. So I pre-book my bike space. That's a landlord system. I then have my device and I want to get through the access control door. It knows my device. That's a landlord system. Lifts pre-called to take me to the 10th floor because of my device. That's a landlord system. I then get to my floor in a tenant building and the access control system to get into my tenant space is now a tenant system. So the interaction between systems and the device hasn't been by those landlord and tenant systems been physically connected together. It's by using cloud and sharing data across cloud. Okay, so the proof of concept that we have with British Land to help them actually deliver this platform, we've convinced them that we should do a proof of concept with our data team at Tom Heath's data team, and that is built around for their head office, their York House head office in Marble Arch, and that is for just very simply, very small contained use case for environmental control in a meeting room, to change the set point, to look at the temperature, and then turn the lights on and off. So it should be really, really, really easy, and something very tangible to deliver quickly. So what you can see, yeah, I'll come to that. So on the left-hand side, we have the lighting control system, which is a Philips lighting control system, proprietary protocol. We have a gateway from a company called North that has an MQTT broker, and we can convert from that proprietary protocol into MQTT. We have a trend control system, again, something like 60-70% of the UK market for HVAC control systems that controls the fan core units in meeting rooms or the whole HVAC within the building. This isn't even on Ethernet, or neither of them are. They're on twisted pair proprietary networks. So we have to convert that into IP, and then we put a device in. This is a Tridium device, sort of biggest integration platform for buildings. Converts from Trend proprietary protocol into MQTT, and then this can be accepted by an AWS IoT broker. This diagram on the right, this AWS diagram, is an architecture built by Sarah Gallagher with James in BPS. And we are working with Sarah and Tom's team to build on this, and then something that we can repeatedly roll out within Arup. Here, and actually a lot of the work that the guys have been doing here is about taking environmental sensing data and then creating dashboards and being able to look and see what's happening with that environmental sensing data. The difference here is that we're adding in a user mobile app, which doesn't need to go through all of this kind of storage and process, but actually says, right, this bit here, Cognito, does authentication to make sure that's a device that should be connecting to it, and then I can then start going, right, I'm going to change the temperature in that meeting room, I'm going to change the scene setting in that meeting room. So people might say this use case isn't that strong. Why would I want to do that when I've got switches on the wall? That's fine, agree with you. But someone in British Land holds the purse strings and they're really keen on this use case. So
if you can get switches off the wall though, is that not a useful thing in itself?
potentially.
that's a useful thing, and also it's also a useful thing to have sort of four, right,
Yeah.
which we can't do at the moment.
So like this one here, no one understands how to operate it because you put a man in the house to switch it on. And, so it's really not, and that's the other problem with interfaces in building systems. They're really not intuitive. They're not like a Nest device at the home, which is just, you don't even need to be told how to use it, you just know. So that's another area where the buildings industry could really kind of push forward.
I mean, I would say there is a way that it's done in meetings through the Crestron type.
Yeah.
Integration.
The
But
point is,
that's very much at the edge.
the point is you can't update the user interface of a switch, but you can on an app.
But the other point is, you just described the Crestron interface, which is really brittle, right? Which is exactly what I've described we want to move away from by the common naming, because as soon as something changes, the Crestron system breaks because it's all done proprietarily. That was it. So, any questions? James,
Did you talk about the bottom left of that diagram?
which diagram?
I missed that last slide. Did you talk about the bottom?
This one?
Yeah.
Okay, so this is their lighting control system.
Okay.
This is a Philips lighting control system. It's like from the early 2000s, we think, maybe. It uses something called LON. So LON and LONWorks was about that time was going to be the open protocol savior of buildings, but basically they had a royalty for chips. So if you wanted to have a LON device, you had to pay for the chip to put it in your product, and that just died a death because of that kind of lock-in again.
And the North device, is that a software-defined switch?
So North are just like Tridium.
Why?
They are a company that writes drivers and has a product for converting from things like that are proprietary to get into something open. So again, this is a typical example. We need these gateway devices to get into the language that we want. In the future, these new systems might not even be lighting and HVAC systems. They'll just be intelligent devices that announce themselves, that say, hello, I'm here, I am XYZ, and here's all my tags. And then it's just, you don't even need to commission the systems or the buildings. It's done.
Is this the one that Jason Giddings was working on? Like using the code for the intelligent asset management system?
Yeah.
Yeah.
Well, it's a lot of this stuff overlaps.
Yeah.
There's a lot of us working on.
So, and also, so the Property Insight program that I mentioned that we're running for the proof of concept, our first project, and it's great that we're in this meeting room actually, so our first project is Workplace in the Cloud, and that is all about number 8 and understanding data from number 8. The first little proof of concept is around meeting space utilization. So understanding using existing systems like the lighting systems to know whether a room is occupied or not, getting all of that data into one central place, and then taking all the data from the Condeco room booking system, and actually then we can start looking, okay, so our rooms are always booked, no one can ever get them, but when I walk past, why are they always empty? We always seem to have, for instance, I'm making this up, I don't know if this is true, that 12-person meeting rooms only have 4 people in them. So why aren't they using the 4-people meeting room? Is it because they're too small? Is it because we don't have screens in 4-person meeting rooms? What's been the impact of a refresh with all of the new furniture? Are all of those spaces being utilised? Which spaces are better than others? Can we start putting sensors on those to understand that? So it's kind of that's, so there's various sensors in here that are looking at how we understand what's going on in meeting spaces. So we'll start with meeting spaces. The intent would then be to go to space utilisation on floors. Is our office only 50% utilised? Could we be using that space better? So on and so forth. Right, well, should we have a bet? What's the odds on that?
So, yeah, this is the controller for the lighting system that Francesca gets up at the
I can put it up actually if you want it. But
I mean, so you can actually promise if you come close to the screen you'll be able to see that that actual sensor's firing in the last hour, but in the previous hour it wasn't firing at all, so this room was actually empty before our meeting.
What's the address, Adam?
I'll send you a link. Yeah.
I've got another question, Richard. External BMS controller manufacturers, are you actively engaging with them and telling them our ideas? If so, how are they reacting? Because I know in the past, Downs talked to the presentation about this stuff, and there was fierce opposition, obviously, because this is their market. Are you talking to them, and what's their response?
So I'd say there's two different questions to answer there. I'll take the second one first, was Darren's presentation. Darren's presentation was like all about open source control systems. Nothing I've said today is about open source. It's just about getting naming right,
Yeah.
and making sure devices are secure and adhere to the right standards.
Okay.
I do support that Darren's ideas there about open source, and because, as I said earlier, these protocols and buildings aren't open because each system has its own proprietary tools that you need to use. So, and actually, when each device becomes intelligent, that model will just be broken anyway because you won't be using those manufacturers' engineering tools anymore.
Yeah.
So that answers the second part. What was the first part again?
You're engaging with suppliers.
Suppliers. Yeah. Okay. So yes, we are. So, and this is an interesting point. It's much easier. So some of the really big players are much harder to engage with. Some of the small to medium-sized companies are much more open-minded, like say Simtronic, like EasyIO, that will allocate their R&D work to align with some of our suggestions because they see the opportunities with the clients that we're working with, and also because they see it just makes sense. And it's just really hard with those bigger companies to get them change the direction, just like it's really hard to get Arup to change its direction sometimes.
At some point, everything will be like this, and then
Yeah.
these companies will have to rethink their entire business.
Well, we know they're already thinking about
Yeah.
it, right? So they're going, okay, our model has historically been about we sell product, hardware, boxes into buildings, and then we lock into maintenance contracts.
Yeah.
Now it's right, okay, hardware is becoming commoditized, can we lock you into services? So can we offer a service at an application level that offers you lock-in? And that's where the new kind of products or offers in the marketplace are around product as a service, software as a service.
Yeah.
So I buy a sensor I get a sensor like that, I don't buy it, I buy a monthly contract to it, and I'm then kind of locked into their platform, the whole ecosystem.
You know the architecture diagram you showed with all the lab, the one that you were developing with the phone and the
For proof of concept, yeah.
I was wondering whether do we know if the AWS stack was in a production environment, so it was on the AWS corporate network, what sort of changes we might need to make?
So the simple answer is no, but I don't know the answer to that.
I think so. Sarah's team have their own AWS account.
Okay, so I'm going to come on to that. So I think that's a different question to what you're asking, though. So
Yeah.
there are various AWS accounts in Arup. We will use an AWS account, a separate AWS account for this project that isn't Arup's. We will have shared intellectual property with British Land. So the AWS data software that's created will be passed to British Land. So they will either take that account, or we will wrap up the software so it can be put into their existing account. So there's one of one of two options. Your question was around, does this stack up with our corporate network?
Well, yeah, I mean, if it was on let's say a production account, so it was on a managed Arab
Okay.
environment, what changes might be
Okay.
made, because that's on the sandbox, which is outside.
Okay,
Yeah.
so I've shown a stack.
Mm.
You've assumed that stack is going into that
Yeah.
AWS account. It isn't.
Isn't it?
No.
Okay.
So there will be a new AWS
Yeah.
account created that will be created by Arup. That will be passed to British Land. It will become their AWS account.
So it's got to go on their production. It's going to be, or is it just going
No,
to be
it's a proof of
Proof
concept.
of concept for them, yeah.
If it works, they will
Yeah.
either then put that AWS account into production and scale it, or they will migrate it into their existing AWS platform, their account.
Yeah.
The code and the architecture that's created and sits within
Mm.
is shared intellectual property.
Yeah.
So we will have the right to recreate, reuse it, however we want.
But there's probably some more development steps before the end of, if you know what I mean. Even if we got the proof of concept going, the sort of handover and potentially
Sure. But-
productionizing of it, there would be more development work to
So
do.
this is a proof of concept to convince British Land that they're building a big smart platform, that we're the people that can help them build their software platform. We met with AWS on Friday with British Land, and they were like, not really sure why we're here. Your architecture's bang on. You know, you guys go and get on with it. How can we help you? So I think what you're talking about are semantics that will iron themselves out at the. Aidan, my point is, I'm sure that they are difficult problems to solve, but we haven't even delivered yet. If we screw this up, it doesn't matter how we get it into a production environment, because British Land won't be buying it.
Yeah, fine. I'm not
Yeah.
talking about screwing it up.
I know you're not.
Yeah.
One last question from Matt. How far down the line we are with integrating this into BIM?
Okay, right. So yeah, that's really important. So the approach that I talked about and showed you specifically for the naming convention has been applied on projects that are already past the design stage or past the point where we can implement it into a workflow with BIM and Revit. We're now starting on two projects. One is just an Arup internal project, separate from British Land, which is the Museum of London, which we will implement it into the BIM workflow. So for every family within BIM, we'll have an extra parameter that will define the JSON payload that I've described earlier with all the additional meta information and the naming. So that automatically what can drop out of that is a schedule of all the points, an asset register, etc., etc. So that's a really good way to sort of optimize and automate workflows. We're also doing the same for Blossom Street, which is a British Land project. That's also mainly being designed MEP by Arup, with some of the other QCIC of a security consultant. And the intent is to work that into the BIM workflow as well.
So the family, they already exist?
So it's just the BIM families that already exist.
Like
It's like the air handling unit, the supply fan, the heating coil, and then it will be an extra parameter on that family to put in.
Okay. So we need to modify the families to include this parameter.
Yeah, so for Museum of London, we've taken an air handling unit, a pump and a distribution board, I think, and over the next 2 weeks we're going to trial that, because they're in partway through stage 3. When that is all ironed out, then they will start adopting it for the whole Revit environment and model.
Okay. Mario, how much does that cost to modify every family by adding a parameter?
No, the point is that we have standard families across the regions.
Modifying standard families.
So
Yeah, no,
no.
exactly, that's why I
So the
was-
feedback from Dave Seeger is yeah, it's just like it's a second to add in an extra parameter.
Yeah, right click, add parameter,
yeah,
yeah.
close.
And then it's for work for the
Yeah, exactly. That's you have a lot of fun because you have
yeah. So
find 2 or 3, but we have
so then it's
lots
about how we find a workflow to automate that
Yeah.
generation process. Until we actually try it, you know, we're not
yeah,
going to.
no, I totally agree. That's why I was asking, is this parameter been added already? Like it exists? So yeah, we're still in the process of doing that.
Yeah. So we can do it.
To do across whole batch.
Yes.
Yeah.
Yeah.
So there are ways to automate it.
Oh yeah.
So we can do it manually, right?
Yeah.
And die and get really bored, or we can find a way to,
Yeah.
to kind of automate it.
Yeah. Okay.
Yeah.
Thank you very much, Richard.
Pleasure. Yeah. Any questions after? Happy to
Yeah,
answer.
yeah.
Yeah. Thanks. Yeah, we didn't talk about this, did we?